Hello, I'm back with another video of Python interview hack by Python Academy. Today I'm with the topic called singly linked list, and we are going to see how to implement singly linked list using Python. Now in this, let us understand first of all what is singly linked list. Singly linked list is a linear data structure. It is the collection of data elements called nodes. So node is like this, as you can see on your screen. It has two parts. So let me explain more about it. Each node has two parts, as you can see on your screen. The left and the right, these are the two parts. The first part contains the data. As you can see in the first part, the data is stored, and the second part contains the address of the next node, that is the ID of the next node. The linear order is maintained by means of links or pointer. Now in this data, the data part may be an integer, or it's a character or a string or object of any kind. Then next we are going to see is chain of nodes. Means when we create a singly linked list, it is a chain of nodes. So it looks like this. The chain is like this. As you can see, there are 4 nodes here. The first one is the data A, the second is data B, the third one is with data C, and fourth one is with data D. And as you can see, the second part is connected with each other. So I have told you, the last end part is containing with the reference ID, or that is called link, and the link is connected with the next node. So hence, as you can see, the chain of nodes is continued and it ends with the last value as a null. Means wherever the last portion is mentioned as a null, it means it is the last node of the chain. In further, what is node? So node is the linear collection of self-reference structure called node, and it is connected by the pointer link. This is the pointer link. It is accessed via pointer to the first node of the list. The subsequent node are accessed via link, the pointer members stored in each node. For example, as we have seen, we have 4 nodes. The data of each node is A, B, C and D. So the whatever ID is of the node B, second node, the ID or the link is stored here, means at the second part of first node. Means suppose if we have the ID of this is 110. Okay, suppose the ID or the address of this node is 111. Suppose the ID of this node is 1, 1 and 2. So the ID, the data is A, so is stored in this first portion, and it's here the pointer is always point with the ID, that is 110 with this. Again the ID is mentioned, link here is 111, and here 1, 1 and 2. Then the link pointer in the last node is set to the null to mark that it is the end of the list. The data stored dynamically. What is the data stored dynamically? Means that each node is created as necessary. It is created as per the requirement, and the length of the list can be increased or decreased. Means this is totally a flexible. As I have mentioned it as a chain of the node, it means the chain can be created with as much nodes we want. So it can be increased or decreased as per the requirement. Now we are majorly focusing on implementing the chain using the Python. So now let us see what are the operations, various operations we can perform here. The list of operations in the singly linked list are: the first one is insertion. So insertion includes the insertion of node at the front, insertion of node at any position in the list, and insertion of node at the end. So these are the various operations or the steps included in the insertion operation. That next operation is deletion of nodes. So it includes deletion at the front, deletion of node at any position, and deletion of node at the end. And the next operation is display. Display is also termed as transversing. So displaying or transversing the element of the list. So operation called display includes the displaying or the transversing of the element of the, within the list. So these are the three operations which can be performed in a singly linked list. And now let us focus on how to create a code, or how we can make a code for singly linked list in Python. So let's move on to the coding part. Now let us see the coding part. First of all, before initiating, I want the important thing I want to bring in your notice is that you must have a knowledge about classes, the object oriented programming for this singly linked list. You at least you must know what is the class and what are the objects and what is the instance method. So after if you are having the knowledge of this, you can easily make the code for singly linked list. As basically singly linked list is not the default data structure of the Python, so hence we have to bring the flavor, or we have to bring the effect of the same along with certain methods or certain procedures. So for this purpose, we are going to use the procedure of object oriented programming, that is with the help of classes and with the help of objects as well as certain methods, we can create a singly linked list in a Python. So for that purpose, I am going to make two classes here. First class is for generating the node or initializing a node. So what I have done, I have made a class called node, and as you know, the node has two parts. One is data and another is ID or reference of the next link. So what I have done, I have initialized this with the default constructor along with the argument called data. So this I have made as self.data equals to the data, means whichever data we are going to insert while calling this class, it will be addressed here. Then as now at the beginning, if it is a single node, its link is always a null, and in Python null is written as none. So what I have done, as it is the single node, so obviously its end link is a null here. So null is written as none, so I have written none. Now I have created another class which is called singly linked list. In short, I have written singly LL. So what it means, this class is made for the purpose of creating singly linked list. And as you know, whenever we create a chain of singly linked list, the first node is always initiated or pointed with a pointer called head. Hence I have initiated a head equals to none. it means it indicates that there, as of now, there no node is created, no chain is created, no list is created. So initially the head is none. Now I have made a method for showing the syncly linked list. Before continuing, let me tell you that in this video I am going to make show you how to see or how to display the singly linked list. In this video only we are focusing on that, and then I will continue with another operations which we have seen in the presentation, that deletion and insertion. So deletion and insertion I will cover in the next part of the video. In this video only I am focusing on displaying the list. Then what I have for this, let us understand the code. So what I have done, I have mentioned the condition here. If the self head means this one, is none, it means what happened, if there is no node is created or no list is created, it means the pointer head is null. So obviously if no node is created, then it will show you the singly linked list is empty, right? And if it is not, then I have mentioned the else part here. So if it is not, then I have taken a variable called temp, and I am assigning it with a self dot head here. So what it means, that if you are creating a first node, so first node is always initiated with the head part. So that's why I have first of all written that if I am going to create a node, then it will initiate it with the head, and then I am going to put the loop here. I am going to put a loop, while loop, because while loop is used when you know where to stop only. So for that purpose I am going to use a while loop, that whenever the loop should continue till the temp is not none. So inside this body what I have written, if the node is created, then print the temp dot data, means whatever the data of the first node, it will print it, and then the next action will be taken as the temp, means this temporary variable will be assigned with the reference ID of the next node. As you know, node is with two parts. First part is with the data, and second part is with the reference of next link. So that's why I have, as a first action I have taken, that it will assign with the head part. The first node is assigned with the head part, and once the data is assigned to it, the next action will be taken as the same temp will be assigned with the ID of the next node. So it will continue till the temp is not none. So this is my code, and here I have taken an object called E, and I am assigning with the class to it, and I have called the method to see whether the node is created or not, or whether the syncly linked list is there or not. So as of now, no node is taken, no link is made. So if I run this, it will show me the syncly linked list is empty. So as I told you, we will focus on the display part. So here I am displaying the current position of the syncly linked list. There is no node is created, no chain is created, hence it is showing me the syncly linked list is empty. So here I am going to stop for this video only, and in the next video we will see the other operation, that is inserting the node and deleting the node. So thank you for watching.